Okay, so the whole idea of this is to get better at problem solving. So I want to see how consistent I can be posting videos, solving problems. I'm using this course, boot.dev, learn data structures and algorithm in Python, and algorithms in Python. Yeah, so the whole idea is to start with this and then maybe transition to, not maybe transition to neat code and lit code. So I'm going to just walk through the code through and look at the answers. But it's going to be the free course. It's not the paid one. It's not the paid one. Right. Let me see. I think someone has gone through it before.
And it tells us exactly how to do it here. So, right? So, all we do is we're going to set minimum to.
I don't know if this guy eventually paid.
The next thing we push
paid course.
Time.
Rhythms.
So
Vertices equals.
this will be da 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 da. Let's see.
I'm
That's
33.
basically the idea that I want to go for.
I'm 33 years.
Let's go through the courses and see how I can get better. So I'm going to do it in Python. Python because Python is a different language and I use JavaScript at my current place of work, but I just want to use Python. Python is easier, I guess. Maybe not easier, but is more just something different. I just want to use something different. I just want to use something different. I just want to use something different. But I'm just looking at this guy's own.
Save some skin. Time. And I'll MP. An XP potion achievement unlocked. This achievement. Alright, beautiful. What we say. I'm in the dark vampire.
Okay, that's cool. Da, 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 da. So let me see how much it even costs for the free. If you're going to pay for the 11,000 per month, you want to complete a single course. Not bad. Let me see. Let me see if this would work. Let's say 11. Maybe I can come back to this. See how if it's something worth it, right? Let's just start the course first. So let me see where's the course dashboard. So I'd already started. This was just basic introduction. Just retreat, just basic introduction. And the second question, this is the first question. Find minimum. As mentioned, an algorithm is just a set of instructions that can be carried out to solve a problem. It's not any more magical than that. In this course, you'll be building pieces of a pretend social network locked in. Is a place for professionals to virtue signal about how all the for profit they will do actually work, and it's actually an altruistic endeavor. Since Facebook meets a job fair, it includes tools for influencers to track their growth. We need to show users the accounts they follow with the lowest. And show users the accounts they follow with their lowest follow accounts. This will help them know who they follow that isn't popular enough to be worth following anymore. Okay. So let's say my accounts, I see the accounts that I follow with their follow accounts and the lowest. Implement defined minimum algorithm in Python, completing defined minimum function. It accepts a list of integers norms and returns the smallest number in the list. So this is like a checklist. They just basically use it as checklist. Well, so pardon me, it's been a while since I wrote Python, but I mean, I guess that's what I hear. It also set minimum, so a positive infinity. So minimum float inf positive infinity. So this norms is a list. Yeah, I set a list of integers norms and returns the smallest number in the list. If the list is empty, return none. So if norms, I think Python is length, right? I guess the length of it. If the length of this is equals to 0, return none. Let me see. Length of a list. Length of a list Python. Yeah, so this returns the list of this. Yeah, so correct. So if the length of this guy is 0, want to return none, right? Then now we are now iterating through each number in this list. Set minimum to positive infinity. Why are we setting minimum to positive infinity? Like floating value if the value is greater than any other finite number. Here the command which represents. There's a Python tutorial that I have. So this guy just helps with like visualization of Python and every other language. So you can just, let me see, just copy this guy and see what it returns. Unexpected indent. Python. So it returns infinity. Okay. So this is float. Let me see. Okay, it's the same thing. So it just returns infinity. Returns infinity. Yeah, because I'm printing a string. Set minimum to positive infinity. Okay. What does this mean? The phrase indicates the implementation of the verb intended to store minimum value. Oh, okay. Any final encounter yourself will be smaller and those will become the new minimum. Element within conjunction. By setting the initial minimum, it guarantees that any finite number encountered during the set will be smaller than this initial value and thus will become the minimum. So you are comparing every number to this minimum value, and then if the number is smaller, then you now equate it. Okay. This guy is basically giving us the answer now. Okay. So for each number in norms, right? Compared to minimum. So if the number is less than minimum, set minimum to that number. If the number is less than minimum should be that number. Then minimum is now set to smallest, and then now return minimum. So let's say the list is 10, 20, 1, 0, right? So I set these guys to the minimum and infinity. positive infinity, minimum positive infinity, and then it checks the length of this. So if if the length is 0, so if there's nothing inside this array or in this list, it just returns none, right? So but for none, it compares. So if 10, for 10, it starts with this very first one, 10, and it checks if 10 is less than this. So this just makes it the smallest number basically. So it stores 10, then it checks if 20 is less than, if 10 is less than 20, because now this number is now 20. It checks if 10, what we stored before, is less than 20. 10 is less than 20, right? So 10 still stays as that. Then we come to 1, right? It checks is 1 less than 10, right? Then 1 is obviously less than 10, so 1 now gets stored as this. Then it checks is 0 less than 1. 0 is less than 1, so it now returns 0. That would be for this case, right? Well, let's run it and see. Yeah, so we see passed. So these are the inputs. 12. Okay, no, these are other sample cases. 7, 4, da 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 da. It returned 1. 12, 4. Yeah, this is basic. It's pretty simple. Nice. Let's see the solution. This reduce XP. Yeah, let's see. No, I don't have any XP. If number in norms. Yeah. Yeah, so submit. Nice. 200 XP. Ooh, they minus my XP. Wow, that's crazy. Okay. Let's see. Let's see the second one. So now, what's an algorithm? In the context of computer science, an algorithm is a finite sequence of well-defined computer implementable instructions. In short, an algorithm is defined. There is a specific sequence of steps that perform the task. It's unambiguous. There is a correct and incorrect interpretation of the steps. Implementable, it can be executed using software and hardware. So it's defined. It's unambiguous.
An algorithm is just a good set of instructions. If you've ever assembled IKEA furniture, baked a cake, or solved a Rubik's Cube, you've used an algorithm. An algorithm must be 3 things. First, defined. There must be a specific sequence of steps that can be taken to perform the task. It must be unambiguous. An implementation of the algorithm cannot be up to interpretation. The implementation is either correct or incorrect with no in between. 3, it must be implementable. An implementation of the algorithm cannot be up to interpretation. The implementation is either correct or incorrect with no in between. 3, it must be implementable. This means we need to be able to carry out the algorithm either with hardware or, more commonly, with software. In computer science, we want to write fast algorithms. Here's a Python implementation of an algorithm that finds the longest string in a list. It keeps track of the longest string so far in a variable. It iterates over all of the input strings and compares them to the largest so far. If it finds a longer one, then that string becomes the new longest so far. By the end, we're guaranteed to have found the longest string in the list. But how fast is it? Well, if there are only 5 strings in the input list, it's almost instantaneous. But what happens if we pass in 5 billion strings? These are the kinds of questions we ask when we're studying computer science.
Interesting. Algorithms are written in pseudocode, pronounced pseudocode, because an algorithm is a high level solution to a program. An algorithm does not care if it's written in Python, Java. Pseudocode is just plain English that describes this basic stuff. Algorithms must have a finite number of steps here. Yeah, that's correct. Let's see, explain. Okay. Increase termination. Okay, fine. Let's go to the next one. What does the pseudocode
An algorithm.
The same thing. What does the mystery pseudocode do? I think I've answered these things before. Starts with an original string called S and an empty string called R. Loop through S from its last character to its first character, and for each one, add it to R. So I have an empty string X, so let's say John, and an empty string R. Loop through S from its last characters, so that's N in John, to its first, and for each one, add it to the string of R. Return R. Okay, so yeah, I'm just reversing here. So I'll add from N, add it to R. From N in S, add it to R. H, add it to R. O, add it to R. J, add it to R. Then once you process, return R. So reversing the string. If you've heard visually exaggerated stories about lit code, haha, that's why we're here. The necessary evil about stories and web, you might hear the word algorithm and it's synonymous with hard problem. That's not really the case, and believing it will only suck you. We suffer more often in imagination than in reality. Algorithms, like anything else, can be understood by breaking down piece by piece. Take a look at the following algorithm for adding two numbers. It's dead simple. Start with input A and B. Start with input variables A and B. Add A and B. Sorry, my phone keeps buzzing. Using the plus operator and assign the result to a variable. Assign result. That's pretty simple. For the logged in influencer dashboard, we need to calculate the total reach of a group of influencers. So it's slightly modified variable. Instead of adding two numbers, it accepts a list of numbers and returns the sum of them. The sum of an empty list should be 0. Okay. So we have it accepts a list of numbers. So let's say 1, 2. So let's start with 0, right? Okay, so let's start with an empty list, and then we have 1, 2. So this should give us 0. It should give us 3, right? We need to calculate the total reach. So we are calculating the total reach of group of influencers to calculate the total reach of a group of influencers to estimate how many views a post it gets if you. So you're just looking through the entire list, and then for each one, you're adding it together. So you have a sum variable. You have a sum variable 0. Let's check first or we can just check immediately. So we check if the length of the array is 0, return 0, right? So then we now get the sum. We start at 0, right? So for num in nums, right? So let's say we have 1 and 2, right? So we get 1. Sum is equals to so we just add it to sum, num plus sum. So for the first one now, right, we have 1, right? So we now say 1 plus 0, right? 0 plus 1, right? This sum now becomes 1. This sum now becomes 1, right? Then it goes again. 2 plus 1, right? Because our sum is 1 now. Then that's 3. Then this sum now becomes 3, right? So then it keeps going. Then when you're at the end, you now just return sum. Yeah, I think that's basically it. So in case here we have 1, 2, 3, right? So this is now 3. So it now goes to the next one, 3, and then Oh crap. And then 3 is, oh crap, the power just went out. I need to turn on the inverter because I can't see my monitor now. Yeah, I need to. 1 minute. Let me pause. Can I pause? Okay, I am back. So power went out, so I had to go turn on the inverter. So where were we? Yeah, so so we're just going through the another sample case. So now we have 3. That's in the case of this, right? So we now goes through the last element in the list. Then I have num, which is 3, and then the sum, which is already 3. So this now becomes 6, right? So 1 plus this 2, 1 plus 2 3, 3 plus 3 6. So it just returns 6 at the end. Yeah. So if the length was 0, it returns 0. I think it works. Let's run it. Ooh, passed. Nice. 6 skipped. What does that mean? What does 6 skip mean? Oh, okay. It doesn't run the entire test case. Test cases when I click on until I submit. Okay, makes sense. Moving forward, now exponents. So we're done with chapter 1, which was algorithms intro. So now exponents. I promise we'll get to how to relate encoding, but first we need to review some math stuff. So maybe I can just do this entire chapter and then I'll come again tomorrow to continue bigger and sorting algorithms. I promise we'll get to how this relates to coding, but first we need to review some math stuff. An exponent indicates how many times a number is multiplied by itself. For example, 5 times 5 times 5 times 5. So 5 exponent 3 is 125. Sometimes exponents are also written using the correct calculate an exponent in Python. 2 times 2, that's 4. 4 times 2, 3. Okay.
Exponents are super easy. Really, do not let the complicated, confusing name get to you. An exponent is just a mathematical operator that multiplies a number by itself a certain number of times. But before we go deeper into that, let's just review some even more basic math to make sure that we're on the same page. As you know, 2 times 2 is 4. We're saying that we have 2 2's. Similarly, 3 times 3 is 9. Again, we have 3 3's. It's really 3 plus 3 plus 3. 3 times 2 2's. We have 2 is 4. As you know, 2 times 2 is 4. We're saying that we have 2 2's. Similarly, 3 times 3 is 9. Again, we have 3 3's. It's really 3 plus 3 plus 3. This relationship between multiplying and adding is very similar between exponents and multiplication. 2 raised to the power of 3 just means 2 multiplied by itself 3 times. So 2 raised to the power of 3 is 2 times 2 times 2, which is 8. 2 raised to the power of 4 is just 2 times 2 times 2 times 2, which is 16. And 3 raised to the power of 5 is just 3 times 3 times 3 times 3 times 3, which is 243. So the results of exponentiation actually get really big really quickly. 2 to the 6th is twice as big as 2 to the 5th. Okay, now that you get that, let's go over just a couple of special cases. Anything raised to the power of 1, that 6th is twice as big as 2 to the 5th. Okay.
32 plus 32.
Okay, now that you get that, let's go over just a couple of special cases. Anything raised to the power of 1 is just itself. So 4 raised to the 1 is 4, and 5 raised to the 1 is 5. This one's pretty obvious. This one's a little weird though. Anything raised to the power of 0 is actually just 1. So 5 raised to the 0, 1. 7 raised to the 0, 1. So how do we do this in code? We obviously can't use superscripts because code is just plain text. We don't have that kind of fancy formatting in our code files. Well, Python is actually one of the few languages that has built-in support for exponentiation in the language itself. And the exponentiation operator is just star star. It's like two multiplication symbols. So 2 to the third in Python can be expressed as 2 star star 3, which will evaluate to 8, or 3 star star 3, which evaluates to 27, 3 to the third.
Q. Okay, in the social media industry, there's a concept called spread. How much a post spreads due to reshares. After all of the original authors follow us, as it turns out, social media posts spread at an exponential rate. We found out that the estimated spread of a post can be calculated using this formula. In the formula above, the average audience followers is the average audience followers is the average of the numbers in the audience followers list. The list contains the individual follower counts of the author's followers. For example, if audience followers is 2319, the author has 4 followers. Each follower has their own followers respectively. Get the estimated, oh bro, I don't even understand what this is. Let's see if this guy can explain it to me. Bro. If this is empty, what should the function return in this thing? Empty. How do you compute the average number of lists in a Python? What two values do you need? In Python, which that one gives you what does not follow the how do you get from the list? After you calculate the average, how should you combine them? Try sketching this. Handle empty list, calculate average, compute the exponential power, return the product. What do you get if you test 1, 1, 1, 1, 1? So this is 0, empty list. The average of this is 1 plus 1, 2 plus 1, 3 divided by the number, the total number. That's 0. 0 exponent 1. Huh? This is some math stuff. I should know this. Okay. Let's see. The average audience followers is the average. Sure. Is the average of the numbers in the audience followers list. Okay, so average audience is the average of the numbers in followers list. So I get the average audience on the follower list if I divide it by the total. Okay. So this is the audience followers, right? And I get the average of this when I divide it. The author has a total followers. Okay. So complete the get estimated function by implementing the formula above. The only input is the audience followers, which is the list of the followers count of all the followers the author has. The only input is the audience followers. This is the average now, which is the list of complete average. So let me use this guy. So if the audience followers, as usual, we check if the length of this is 0, we just return 0. Followers is 0, we return none, or return 0. I return none or 0. It is 0, okay, 0. If it's empty, return 0, right? Then check. Okay, so you calculate the average. So average audience followers is equals to if audience followers let's get the average. If I want to get the average, I have to sum the entire list and then divide it by 2. How do you compute that? What 2 values do you need? I think I need to. Do I need to iterate? So I need to get the sum. Oh, or the length. Is it the sum or the number? How do you get average self? How to calculate? Add up all the numbers in a set and divide by the sum. Add them to get 12. This is 10, 12, and divide them by 3. So I add them the sum and then divide it by the number, the total number. So I have to get the sum. So I have to get the sum of the average. So for num in audience followers, right? I have to sum equals to num plus sum, right? So this will give me the sum. Now that I have the sum, I want to divide the sum by the length. Find the average, okay, then and then divide by the count. Get an average of 4. So I now say average followers will be the sum divided by the length of audience followers. This is how you divide in Python. This should be performed using the double slash to divide the first number and result in what's the nearest whole number. So I think I'll use the normal one, the normal division. That's just 1 slash. So this will give me the average. So let's say I have followers. I have 1. Okay, let's say I have 2, 3, 2, 19. Right. So I sum this up. So 19 plus 2, 21, plus 3, 24, plus 2, 26. Right, so this is the sum. Sum is 26, and then I now say 26 divided by, I say 26 divided by the length of the followers, that's 4. 26 divided by 4. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. So yeah, so that is going to give us, this will not work. So this will be 4 times 6, 24, right? So this will be, I'm dividing 26 by 4. So remember that, so right? So this will be 5 points. What am I doing? Four times 7. 28. 4 times 5. No, this will be 6. Oh, yeah. 6 points. 6.2. 6.2. So I want to flow it. So just give me 6. So just give me 6. Let me see. How do you get from the list? So now that I've gotten the average, compute the exponent part. So I want to use, let me see, divide Python. I divide up to the nearest whole number. Yeah, so you should just give me, I'll use the second one, double infinity. So this should just give me 6. So the average is 6. That's the average audience followers. Right, the average is 6. Okay. Then when formula calculates the average of the numbers, this contains the number. For example, the author has 4, each follower has his own. Compute the audience by the only input is the audience follower, which is total of number counts. Compute exponent parts. Estimated spread. Okay, then I say the estimated spread is the average audience times the length of this. So let's say non-followers. What's non-followers? Is it the total number of followers? Is that the total number of followers? Yeah, it should be the total number of followers. So let me change this to, I can just make this sum now. Yeah, I can make this sum. So you're getting the estimated spread, the average times the sum, exponents. No, this will give us exponents. Why is he using this guy? Sorry. Okay. Let me go through this again. So you can get the spread from this formula. You can get the spread when you get the average audience followers, non-followers, and this. What is this?
Exponents, special case.
Caret. Can't use this is pseudocode, I guess. That's why using caret. But it's supposed to be star star. Okay. So in the formula is the average of the numbers in the audience followers. So this is the average. The sum of this divided by the length of these followers. Right? The list contains the individual follower counts of the author's followers. For example, if the audience followers is this, the author has 4 total followers. Okay. Is it the sum? Complete the derivative by implementing the formula of the only input is the audience followers, which is a list of the follower counts of all the followers that has. So I think it's just the length. I think it's just the length. Let me see what this would be. So it all failed. I'm not doing something right here. Do I need to get the sum? I don't think I need to get the sum, but I need to get the sum now. So I've gotten the average. The average is the sum of this divided by the length of this for num in audience followers. So let me just go through this again. So let's say I have 1, 2, 3, right? So for num here, right? So it picks the first one, num divided plus sum. It gives me sum. So this now becomes 1. Right? So it goes to the second one, 2. 2 plus 1, that's sum. Now becomes 3, right? And it goes to the next one, 3. 3 plus 3, that's 6. Right? So I've gotten the sum. That's quite right. Then I need to get the average. The average is the sum divided by the length. How to get sum. So I can just even try this if average. Using some function. Why is it increasing the counts? Yeah, that's 5 now. So let's say this will go 1, 2, 3, 4, 5. So that's just the length. Why is it? The sum divided by the length. So let me carry this guy and let me see. I can't print. So let me take this guy here. Then I call this function. Result. Passing. Count 1, 2, 3. So 1, 2, 3 should give me this 3, 4, 5, 6. 6, right? So 6 divided by 3, 2. So let's see. So this is 2. Huh? Wait, I'm coming. Let me see. Print result from here. Okay. So where is I'm getting 17 points? Why is it 17 points? Come, let me see. Let me print this one. Some here. Six. This is correct, right? The sum divided by the length. Average. I get the average, right? Then the estimated spread, the average followers times for example, um, some followers is sum of the list or the total of the list. So it's not the total, it's the number. So it should be the number, not the total. It should be the total, not the. So let me say total. So 2 passed. So this is because of my division, I guess. Oh no. Yeah, so this worked. So this is the total, not the sum, not the sum of the list. This is a lot of trial and error, but let's see. Let's work it. Let's understand it again. Should the division or the real division to match average? Okay, so let me try these test cases. 12. So we have 12 followers. I don't think I quite understand this question. I don't think I understand it thoroughly. I guess that's where the problem is. But let's see. So we have, so there's a concept called spread. How much a post spreads due to reshares after all the original authors followers sees it. So let me try and see if I can like make sense of this. How do I clear all of this? So you have an author, you have, bro, what am I doing? You have an author. An author has, let's say he has 2 followers. 2 followers. So follower 1 and 1, right? So after all his followers is another post spread, we found out that the estimated spread of a post can be calculated using this formula. The average audience followers and then the total number of followers and then exponent 1 times 2. The average audience followers is the average of the numbers in the audience's followers list. Is the audience followers the author? How many followers one of the author's followers has? So it's like if this follower has, if this, so let's say Kelvin and John, so the audience followers is number of followers Kelvin has. So let's say Kelvin has 3 followers, John has 4 followers. The author is Michael has 2 followers. There's Michael is the author, and then he has 2 followers, Kelvin and John, and respectively Kelvin has 2 followers. Let's see. Each follower's own follower count. Okay. Okay. So the average audience followers is the average of the numbers in the audience followers. So 2.5, that's the audience followers. That's my followers. That's the author's followers. The author's followers. Funny. This list contains the individual follower counts of the author's followers. For example, okay, the author has 4 total followers. So I have 4 total followers. So I have a total of 2 followers, right? I have a total of 2 followers, and each follower has their own. And out of those 4 followers, one has 2, one has 3, one has 2, one has 19, right? And then the spread is the average audience followers. That's the average of these guys, their followers, times my total exponents that. Okay, I think it makes sense. I think it makes sense now. So I now get the average of the audience followers, which is the sum divided by the total, and then I use the formula. The total is my total. It's the total of the audience followers times exponent 1.2. And y, oh crap, Yeah, this is sum of and then I get the total. That's the length, not total, the length of the audience followers. The exponent is the number of followers, not the sum. Yeah, my bad. Yeah, the length. Got that. And then why is it 1 point? Why am I exponenting 1.2? The spread grows superlinear full account. Using an exponent of 1.2 slightly faster. It's a fitted it's not a mathlog. That's what it choosing. Okay. I think that is fair. I think that makes sense. So exponent quiz. Exponents are really simple once you get the hang of them. 2, 2, 2. Sometimes exponents are also written using the caret symbol. Just to give you a bit of reference. 5 exponent 3 is read as 5 to the power 3. 5 is the base, 3 is the exponent. 2 exponent 10. That's 2 times 2 times 2 times 2 times 2, bro. 2 in 10 places now. I'll just use calculator. 2. Oh boy. 20, 20, 20, 20, 20, 20, 20, 20, 20, 10,000. 10 to the power of 3. 300. 10 to the power of 3. 10 times 10. Oh, not plus. 1,000. Oof. Okay. So let's see another one. Exponents grow very largely, very quickly. Let's take a look at an example of them doing that in code. While the influencers who use our platform are really great at taking selfies. Let me just watch the video.
Say a company earns $100 in their first year of business, and then in the second year they earn $200, then $400, then $800, then $1,600, doubling every year. This growth pattern is an example of a geometric sequence. Each number in the sequence is calculated by multiplying the previous. Say a company earns $100 in their first year of business, and then in the second year they earn $200, then $400, then $800,
4, 2, 6, 7, 8.
then $1,600, doubling every year. This growth pattern is an example
100, 300, 4, 5, 6, 7.
of a geometric sequence. Each number in the sequence is calculated by multiplying the previous number by some fixed number, which we usually refer to as R. And in this case, of course, that fixed multiplier is 2. Let's take a look at another example. Let's say that we start with the number 3, first number in our sequence, and that R is 4. Well, the next number is 3 multiplied by 4, which is 12. Then we multiply by 4 again, getting 48. Then multiply by 4 again to get 192. And then again to get 768. Now, of course, there's an actual formula for this math that we're doing. A sub n, which just means the number that we are trying to calculate, the spot in the sequence that we care about, is equal to A sub 1 multiplied by R raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier, R, is 3. We can just plug that into our formula. A sub 7, the 7th number in the sequence, is equal to 100 times 3 raised to the 7 minus 1, which of course is just 6. And because 3 to the 6th equals 729, 100 times 729 is just 72,900. So that's our 7th number.
So you're trying to get like a prediction. Using the following that's slightly modified for this problem. Should be an easy one. Okay. Influencer type. Okay.
Say
Let me watch
a
that.
company earns $100 in their first year of business. And then in the second year, they earn $200, then $400, then $800, then $1,600, doubling every year. This growth pattern is an example of a geometric sequence. Each number in the sequence is calculated by multiplying the previous number by some fixed number. Each number in the sequence is calculated by multiplying the previous number by some fixed number, which we usually refer to as R. And in this case, of course, that fixed multiplier is 2. Let's take a look at another example. Let's say that we start with the number 3, first number in our sequence, and that R is 4. Well, the next number is 3 multiplied by 4, which is 12. Then we multiply by 4 again, getting 48. Then multiply by 4 again to get 192, and then again to get 768. Now, of course, there's an actual formula for this math that we're doing. A sub n, which just means the number that we are trying to calculate, the spot in the sequence that we care about, which
So A sub n, that's like the spot we're trying to calculate. A sub n, I'll just do n spot. So the prediction basically.
just means the number that we are trying to calculate, the spot in the sequence that we care about, is equal to A sub 1 multiplied by R raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier, R, is 3. We can just plug that into our formula.
So A7.
A sub 7, the 7th number in the sequence,
That R is 4, is it 3? Yeah, R is 3.
formula. A sub 7, the 7th number in the sequence, is equal to 100 times 3 raised to the 7 minus 1. 29, 900, 7,
So the 7th position is.
which of course is just 6. And because 3 to the 6
Okay. So I think it's pretty straightforward. Calculate the number of. It takes a follower count, integer type, and a integer. So returns an integer. Calculate number of followers. So number of followers. Number of followers. After however many months, according to the influencer type. Follower counts quadruples each month. Cosmetic follower counts triples and doubles. Quadruples, that's 4. Quadruple is 4 times. Therefore, 3 times doubles. If a fitness influencer starts at 10 followers, and after 1 month they would have, that's 40. After 2 months, 160. Okay. So I say if the influencer type is equals to the influencer type is equals to fitness. The influencer type is equals to fitness. Return. This will just be funny. Or I can say total equals to A1 or exponent n. Let me see.
In a sequence where the starting number or in the sequence.
So how do I get the first if it takes the follower count? Okay, that's the follower count. Okay, I think that's the follower count. Calculate number of followers after how many months. The number of months. Total number of months. I think this will be the follower count. So it starts at 10 followers, right? And then R is the fixed number. So R is going to be 4. R is going to be the common multiplier. The common multiplier. So how would I get that? This is a funny one. R is the common multiplier. Oh, crap. If it's R, it would be 4 times. I'll just put it there now. So I'll see follower count. Since it's fixed. If it's fitness, it's going to be 4. Exponent n.
Sequence is equal to 100 minus 1, 7.
N is the total. No, n can't be the total. Let's say it's 10. Let's see follower count is 10. Times 4. Times 4. And then your n is
The seventh number in the sequence is equal to 100 times 3 raised to the 7 minus 1, which of course is just 6. And because 3 to the 6th equals 729 in the sequence is equal to that we are trying to calculate, the spot in the sequence that we care about, is equal to a sub 1 multiplied by r raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n is just the index of the number that we're trying to find.
yeah. So we're trying to get the total, not basically.
And in the sequence, in a that comes to the rate
R is common multiplier.
raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that common ratio, the multiplier. And again, n
Then number of months. No, I don't think Nah, I don't think I know what to do in this question, to be honest. Okay, so let's ask this guy. A1 is my floor count because A1 is the beginning, right? Is what I'm going to be using to increase it. Each value is the growth rate for each influencer. So for influencer, for fitness, for cosmetic, for cosmetic 3, and for other 2. And n is the number of months we're applying that growth. That's the same for you want to assign to a return, you copy the value then return. It's a growth rate for each influencer type. Yeah, 4 times. The end is the number of months we're applying that growth. Each month. That one after 1 month. Oh, it grows 4 times. N is 1. Is it always 1, or should we match it how many times we apply that growth? If an influencer grows, say, 5 months, how many times would the rate be multiplied? How would you write rate to the power of months in Python? What if they use to replace? Oh, to be the number of times that they grow. So for 4 times, it will be 4 times. Yeah, for 4 times, it will be 4 times. If they grow 4 times, that means 4 times. So each every 4 months. Five. They grow 5 months, you apply the rate 5 times. So each time n will be so this will be the number of months now. So this will be 4. This will be 4. Let me see. Oh. Cannot wait, it's not assigned to a value. Oh, because it's inside this guy. See the number of months. So fitness is 1 month. Fitness is 2 months. Cosmetic is 4 months. So I'll just have multiple ifs. This is not a good cosmetic. This is not a good way to write this. So total will be the follower count times cosmetic is how many times? Cosmetic is 3. 3 multiplied by its number of months. Then I return. And then if influencer type is order, the total will be follower count times 3 months. Then I return. This is not clean. If I submit, try again. 2 failed. Oh, okay, so I didn't handle that last case. I think there's a last case. Oh, it's supposed to be 2. Okay, 2 failed. Okay, if it's order, if influencer type is. So if influencer type is not any of this. If it's not any of this, if influencer type is not fitness, because it can be anything else, right? It's not fitness or cosmetic. So let me just say order equals to fitness or cosmetic. So if it's not this, if it's not that, then it should be that. Yeah, so this worked, but this is not clean. This is not clean. So let's see the solution. But I think I get it now. So the influencer, so each input has the follower count, the influencer, and the number of months that is going to be increasing. The number of months that it increases. So it either doubles or triples or it quadruples. Right. So for fitness has, I want to check after 1 month, and it has 10 followers already. So it uses this formula that after 1 month it quadruples, so that's 40. After 2 months it quadruples again, that's 80, right? And then it keeps going. So yeah, so I think I'm going to stop here and then continue this tomorrow. But yeah, this was a good recording session. Okay, let's see the solution. So if influencer type is this, return the follower count times this. If it's cosmetic, return the follower count times this. Then if the follower count, or else, okay, if it's not any of the two, then you return the what it doubles, the constant, and then the number of months. Clean. So let's just do it. You can just have it. So if influencer type, so let me just, how will I remove it? Oh boy. So if the influencer type is fitness, you return that's the follower count times, you can put it in brackets, in parentheses, the follower count times the fixed, that is we have 4 each month, number of months, else, no, if it's also, if you check again, if influencer type is cosmetic, you return the follower count times the norms the constant, or what it increases at each, well, how it increases. And if it's none of that, then you just return the follower count, it doubles every month, times 2, and then the number of months. Cosmetic, like this Python, and indented da. Okay. Okay, let me see. This guy should be here. This is basically the same thing now. Yeah. So yeah, I'll stop here and then maybe tomorrow, not maybe, right? Get back at it again. So yeah, nice work.